So we will start today's class. So our first question. So this will be our last class in the NPTEL platform and energy conservation of this course. So we discuss. You can go through all the lectures, last 12 lectures, and one trial video. Also, you can get it from the YouTube link, whatever I shared. So from there, you will get to know about all the problems, how it will ask in the exam, and how it will be now helpful for your things. You can give us a comments also. So now we will go to the first problem. The question is, hot air at 66 degrees Celsius is cooled up to 38 degrees Celsius by means of cold air at 15 degrees Celsius. Mass flow rate of hot and cold air are 1.25 kg per second and 1.6 kg per second respectively. Specific heat of hot and cold air are 1.05 kJ per kilogram Kelvin. Overall heat transfer coefficient is 80 watt per meters 80 watt per meter square Kelvin. Find the surface area for heat exchanger for parallel flow heat exchanger. Okay, so you have to find the surface area for heat exchanger, and that will be parallel flow heat exchanger. Okay, now you have to read the question carefully. Now first we will write the given data available here. So given data are hot fluid, hot air things. Okay, so THI value is given, that is 66 degrees Celsius. TH output value is given 38 degrees Celsius, and mass rate M is given for 1.25 kilogram per second, and CPH value is also given, that is equal to CPC value, it will be 1.05 kilojoule per kilogram Kelvin. Okay, now at the transition, next one is cold fluid to cold air. So it will be TCI is equal to 15 degrees Celsius is given. MC rate is given 1.6 kilogram per second. Here and U value is given, that is 80 square K. So A, how much, that you have to calculate. So these many values are given. Now if you see, if you draw the diagrams, okay, so cold fluid, so TCI, it's flowing actually, and TC output. Okay, now hot fluid, it's flowing, and its output will be TH output, and TCI, this is THI. Okay, TCI, and the flow of here will be TCO. Now if you draw the diagram, it will be TCI will be here, THI will be here, it's going here this way, and TCI is coming here, and this will be THO, and this will be TCO. This output we can take the difference T delta T2, this difference you can take delta T1. Okay, this is hot fluid and this is cold fluid. Please go through the figure, then we will solve the problem. So now we go for the solution part. So in this, the total rate of heat transfer, the Q will be U A LMTD. So you have to calculate LMTD for this system. Okay. Now first we will calculate Q value. Q will be mass rate for HC and CPN THI minus THO. So it will be MC same as MCCPC PCO minus TCI. Okay, so you can write the Q value will be 1.25 times 1.05 66 minus 38. So it will be 36.75 kilowatt, or you can write 36.75 times 10 to the power 3 watts. So then you know that Q is equal to MC from this equation, this part. Okay. So substitute these values also. So you will get this part here. So you will get 36.75 is equal to 1.6 times 1.05 TCO minus 15. From there you have to calculate the value of TCO, that you will get the answer 36.88 degrees Celsius. Okay, now from this part you can get delta T1 value. It will be delta THI minus delta THI minus TCI. So it will be 66 minus 15, that will be 51 degrees Celsius. Okay, student, now if we found T0, then you can calculate the value of delta T2 also here. So how to calculate delta T2 value? Delta T2 will be THO minus TCO. So it will be 38 minus 36.88, that is 1.12 degrees Celsius. So now you have delta T1 and delta T2. Now you can calculate the LMTD. From there you can calculate the area values also. Now Q values is given. Just go through the steps what we did. From that we found it delta T1 and delta T2. Then you just go use the LMTD equation for the parallel flow heat exchangers, then find the area value. I just go through this and we'll go to the next slide to explain that. Okay. Now we will explain the remaining part. LMTD. So how to find LMTD for parallel? We already solved such kind of problems in several classes. So just I'm repeating this because for your last two classes we are just refreshing the problems. Okay, so LMTD formula will be delta T1 minus delta T2 divided by log delta T1 divided by delta T2. So it will be how much? 51 minus 1.12 divided by log 51 divided by 1.12. So it will be 13.06 degrees Celsius. So this will be your LMTD. Now you have to calculate the areas. You have to give that in first equation whatever I wrote here. This first equation we can give equation number 1. Then it will be in equation number 1 you just substitute it, so you will get the answer 36.75 times 10 to the power 3 is equal to 80 times 8 times 13.06. So it will be A is equal to 35.17 meters square. So this will be the answer for this. Please go through it and we will solve the next problem after this. Now we will go to the next problem. So this problem, now if you treat this problem in counterflow method, what will happen? Hmm? Thus you have to draw this 38 degrees Celsius and it will be 15 from 37 to from here 66 to. Okay, now just you have to give Q1 value, it will be 66 minus 37.37, it will be 28.63, and Q2 will be 38 minus 15, that will be 23. Qm you can calculate Q1 minus Q2 divided by log Q1 by Q2, it will be 28.63 minus 23 divided by log 28.63 by 23, the answer will be 25.71. Okay, and in this case area will be, use same equation, q is equal to u a q m. So it, from that you will get the value of area 517 meters square. Okay, so you can approach these two ways, parallel flow also, counter flow also. Please go through it, then we will go for sudden, means soon we will go to the next problem and we will solve it. Okay. So we'll go to the second problem for today's class. In a counterflow heat double pipe heat exchanger, water is heated from 25 degrees Celsius to 65 degrees Celsius by oil with specific heat of 1.45 kilojoule per kilogram Kelvin and mass flow rate of 0.9 kilogram per second. The oil is cooled from 230 degrees Celsius to 160 degrees Celsius. If overall heat transfer coefficient is 420, then calculate the following. First the heat rate, the rate of heat transfer, second one the mass flow rate of water, and third is the surface area of heat exchanger. So you have to find these three for this problem. First we will write the given data here. Maybe Tc1 is equal to 25 degrees Celsius, Tc2 is equal to 65 degrees Celsius, and Th1 is equal to 230 degrees Celsius, Th2 is equal to 160 degrees Celsius. Now you have to, it is given Cph is equal to 1.45, mh is equal to 0.9, U value is given 420, and Cpdc given 4.2. So this many is given. Now just we draw the counterflow part. So it will be 65 degrees Celsius is getting cooling, means 25 to 65 it's flowing this direction, and here to 30 degrees Celsius to 160 degrees Celsius, and here it's going in this direction. Okay, now if we draw the diagram, it will be THI, that is 230 degrees Celsius, and it's getting cool 160 degrees Celsius, that is TH2. And here TC2 will be 65 degrees Celsius, it will be 25 degrees Celsius, that is TC1, and area is given here, and temperature is going in this direction. Now you have to get the weight heat transfer. Heat transfer will be Q, that is Q is equal to MC divided by TH1 minus TH2, that will be is equal to MCCC divided by T times TC2 minus TC1. So it will be 0.9 times 1.545 times 230 minus 160. So the answer will be 91.35 kilojoule per second. Okay, so first we go through this, how it's coming, then we will go to the remaining part. Now we will go to the remaining part. Mm, Mass flow rate of water. So MC will be 0.545 kilogram per second. Okay, so then surface area of the heat exchanger you will get Q will be UAQM. So it will be, so for finding that QM you have to calculate for that Q1 TH1 minus TC2, it will be 230 minus 65, it is 165. TH2 is E minus TC1 is equal to 160 minus 25, that will be 135. Now del Qm will be Q1 minus Q2 divided by log Q1 divided by Q2. So it will be 165 minus 135 divided by log 165 divided by 135. It will be 149.5 degrees Celsius. Okay, now from this you have to calculate the area value. So 10 to the power 3 times 21.35 is equal to 420 times A times 149.5. From here you will get A value 1.45 meters square. So please go through this, then we will go for the next problem. So we will go to the next problem here. A steam condenser is transferring 25 kilowatt, oh sorry, it's 250, okay, 250 kilowatt of thermal energy at a condensing temperature of 65 degrees Celsius. The cooling wastewater enter into the condenser at 20 degrees Celsius with a flow rate of 2500 kilogram per hour. Calculate the log mean temperature difference, and if overall heat transfer coefficient for a condenser surface is 1250, then what will be the surface area to required to handle this load. Okay, so the given data we will write here. TH1 is equal to TH2 is equal to 65 degrees Celsius. TC1 is equal to TC2 degrees Celsius. Q is equal to 250 times 10 to the power 3 volt, and MC is equal to 7500 and divided by 3600, so 8 kilogram per second. That will be and U value will be 1215. Okay, so from here you will get Q value MF HFG to be famous MCCC times TC2 minus TC1, so it will be 2250 times 10 to the power 3 is equal to 75,000 divided by 3600 times 4.2 times TC2 minus 20. From here you will get TC2 value, that will be 48.51. Okay, now if you have TC2 value, you can so from there you can Q1 is equal to 65 minus 20, so it will be 45. Now Q2 will be 65 minus 48.51, so it will be 16.49. Okay, so Q1 be, then it will be Q1 minus Q2 divided by log the Q1 minus, it will be Q1 45 minus 16.49 divided by log 45 divided by 16.49, so it will be 28.3. Then Q value will be UAQM, so it will be 250 times 10 to the power 3 is equal to 1250 times 8 times 28.3. So area will be 8.99 meters square. Now we will go to the next problem. It will be water and its mass and specific is given and is heated from 40 degrees Celsius to 70 degrees Celsius by an oil entering at 110 degrees Celsius in a counterflow heat exchanger. If all overall heat transfer coefficient is 350, then calculate the surface area required. Okay. So given data will give for a cold fluid to water. So that will be same as MC. So CPW is equal to 4.187 kilogram per kilojoule per kilogram Kelvin. That's in CPC. And TC1 is equal to 40 degrees Celsius. TCO is equal TCI and TCO is equal to 70 degrees Celsius. Now hot fluid to oil. Okay, so it will be M0 dot is equal to kilogram per second. Now we have to calculate the area. Okay. So now you're expert. I'm not drawing the diagram here, so you know how to draw it already. Mm, so Q will be UA. You can Q will be UA LMTD. So from that heat transfer Q you can write MHCPN THI minus THO, that will be same as MC dot CPC TCO minus TCI. Then just substitute the values. So you will get 1.4 times 4.187 70 minus 40. So it will be 175.85 kilowatt. Okay. Now Q you can write it as mH bar CPH times THI minus THCO. So substitute these values. So 175.85 is equal to 2 times 1.9 times 1110 THO. So it will be 63.72 degrees Celsius. You will get the THO value 63.72 degrees Celsius. Now what you have to do, you have to calculate as usual delta T1, that is equal to THI minus TCO. It will be 110 minus 70, that is 40 degrees Celsius. Okay, now delta T2 you have to calculate. So delta T2 will be THO minus TCI. So it will be 63.72 minus 40. You will get answer 23.72 degrees Celsius. Now you have to go for LMTD. LMTD will be delta T1 minus delta T2 divided by log of delta T1 divided by delta T2. So it will be 40 minus 23.72 divided by log 40 divided by 23.72. So it will be 31.15 degrees Celsius. And these values we can give it in this first equation. You can call it as equation 1. Then you will get the answer of area. So just substitute those values. Then you will get 1.6 mean 175.85 times 10 to the power 3, that will be equal to 350 times 8 times 35.15. Then you will get the answer, area is equal to 16.13 meters square. So in this problem also, such if you have to find the calculated surface area or LMTD, you have to just know the remember the formulas here, and you have to go for the problem. So just first you write the whatever the values are given and just remember the formula. So in this case you have no value formula for Q value, and just substitute those M M C rate and all this temperature difference and all, then you will get the Q value. Substitute that Q value to find the under temperature. Then from that to find the LMTD, you have to calculate delta T1 and delta T2. Then you find it those values and find the LMTD here. And after finding LMTD, you can get the substitute that in the first our fundamental formula you LMTD. Then you will get the value of the area, surface area for the systems. Okay. So in this course, we solved several problems regarding this energy conservation, waste heat recovery. So you can go through all the videos, and if you have any doubt, you can ask in the comment box. I will answer for that. And just remember, these problems are very important for your exams, and it's related to your assignments also. So please go through all the problems and get ready for your own exam. So we are winding up the class here. This will be your last class for this course. So wish you all the best for your exams and all success. Yeah, thank you.